Hi everyone, I hope you're all doing well. I am making a video for your IXL assignments for the week. So we're doing N5 and N6 right now. I'm just going to share my screen. Cool. So let's go ahead and get started. We're multiplying and dividing rational expressions. So we're working on N5 right now. So you're going to see problems like this. You're just going to want to remember how to multiply and divide fractions. Pretty much the same exact process. I'm just going to rewrite my problem. So whenever it says divide by this number, that's going to be the same thing as multiplying by 1 over. So dividing by that is the same as multiplying by 1 over 5q plus 1. And that's it. Now I'm just going to have to multiply across. So on the top I have 4q minus 3 times 1, which is just 4q minus 3. And then on the bottom I have 5q minus 2 times 5q plus 1. And I'm going to FOIL those binomials right there. So if you guys remember, that's going to be, you multiply the outside first. So that's 25q squared plus 5q minus 10q minus 2. I simplify my like terms right there, and I get 25q squared minus 5q minus 2. So that's the simplified, or that's the expanded version right there. So in the answer, you're going to put 4q minus 3 over 25q squared minus 5q minus 2. Okay. And that's it. So let's move on to the next one. Okay, so you're going to get the same, you're going to get the same binomial sometimes, which is helpful because then you can kind of cross that off before you have to multiply out. So let's just set this up first. So it's going to be 3j plus 2 over 6j squared minus 30j. And then dividing by 3j plus 2 is the same thing as multiplying by 1 over 3j plus 2. And now I can see that I have the same binomial in the top and the bottom of both of my fractions there. So that means I can just cross those off because they'll cancel out anyways. And then what I'm left with, is just 1 over 6j squared minus 30j. And that's your answer. You're going to use the little fraction bar to input that. Okay. This one's just the same thing. You'll notice you have the same binomial 3c minus 6. So you'll just do the same thing. They'll cross off again. Super simple. So I'm not going to do that one. Same thing here. You have 8s plus 20 and 8s plus 20. They'll cross off when you set it up. So I don't think you guys need me to do that for you. Okay, this one's a little bit different. So we actually have a full-on fraction, and we're multiplying this time. So something to keep in mind is what we're trying to do is simplify each of these polynomials by factoring them, so that then we can cross things off that appear in both the numerator and the denominator. They can just cross off if we have the same thing. So let's just see. So I'm going to rewrite 7u minus 1 over 4u minus 5 times, okay, so 8u squared minus 10u, I can see right now that that can be factored. So I'm just going to come down here and try to factor that before I write it. 8u squared minus 10u. So all I'm doing is factoring this binomial. So what do 8u squared and 10u both have in common? Well, they both have a 2u. So what I'm left with is a 4u minus 5. right? So I just put this in factored form. So instead of this whole thing, I'm just going to write my factored form, 2u times 4u minus 5. They equal the same thing. I didn't change it. I just put it in a different form. And then let's go ahead and also factor the 14u squared plus 5u minus 1. That looks like it could be factored. So let's go ahead and try. Okay, 14u squared. Okay, I'm going to need to do my little X method, if you guys remember, to factor this. So on the top, it's a times c, and then the bottom one, it's your b term. So a times c in this case is going to be 14 times negative 1, which is negative 14. And then your b is 5. So what are two terms that multiply to negative 14 but add to 5? That's going to be 7 and negative 2, right? And now, because my a value here, because it's 14 instead of 1, I need to do my box method. Hopefully this is a refresher for everyone. So to fill in my box, I'm going to put my first term. So the 14u squared goes in the top left. My new term, 7 and negative 2, go in my diagonals. So that's going to be 7u and negative 2u. And then my last term, my negative 1, goes in the bottom right box. Okay, and now what I do to find the actual factored form is I'm going to take the greatest common factor from each column. So for example, I have, let's do red, 14u squared and negative 2u squared. What they both have in common? 2u. Okay, and then 14u squared and 7u both have a 7u in common. Negative 2u and negative 1 have a negative 1 in common, and 7u and 1 just have a positive 1 in common. So these expressions I got on the outside are my new factored form. So this is going to be 7u minus 1, and then 2u plus 1 is the factored form. So now I'm going to go ahead and take this. Oops. And I'm going to move it there, because that is the factored form of the big 14u squared plus 5u. Okay, so all I did is I rewrote the problem with my factors on the right side now. So now when I'm multiplying across, I can see that I have some of the repeating binomials on the top and the bottom. So that was the whole goal. So now I have a 7u minus 1 on the top and the bottom. And I also have 4u minus 5 on the top and the bottom. So that makes my multiplication a lot easier if I can get rid of those terms. And then all I'm left with is, well, this whole fraction just became nothing, right? And so I'm left with, I have 2u on the top, and I have 2u plus 1 on the bottom. And so that's my answer, 2u plus 1. Now you cannot simplify the 2u's, right? Because on the bottom, this is a plus sign. It's being added to 1. So you can only simplify the top and the bottom if that term is being multiplied. And 2u is only being added, not multiplied. So you cannot simplify those. So that's your answer, 2u over 2u plus 1. So it really all is just about factoring. Okay, here's a similar one. Okay, well, right off the bat, I can see that I have the same binomial on the top and the bottom, that k minus 3. So I'm going to go ahead and just cross those off right now instead of having to multiply them out and then cross them off later. Just going to save myself some time. So get rid of those. Okay, now all I'm left with, on the top, I have 36k squared minus 1. And on the bottom, I have 12k squared minus 4k minus 1. Well, I am assuming I can probably cancel something out if I factor these. So let's go ahead and factor the top. This is a difference of squares, if you guys remember that. So to factor that, I know it's just going to be 6k plus 1 times 6k minus 1. That's why I factor the top. If you don't remember that, look up difference of squares. And then for the bottom, I'm going to need to do my little diamond and then box method again. Because it's a trinomial, so there's 3 terms in it. So the top, remember, is going to be your a times your c, so that's going to be -12, and the bottom one's going to be your b, which is -4. So what are 2 numbers that multiply to -12 but add to -4? It's going to be -6 and 2. Okay, and so to fill in my box, I'm going to put 12k squared, -6k, 2k, and then -1. And now you just go ahead and find the greatest common factor for each row and column. So let's start with this row right there. 12k squared and 2k both have a 2k in common. -6k and -1 have a -1. And then 12k squared and 6k both have a 6k, and 2k and -1 just have a 1. So this tells me that my factored form is going to be 2k minus 1 times 6k plus 1. So that's what I'm going to write up here in factored form. So I have 2k minus 1, 6k plus 1. Okay, and then we'll see that I have the same binomial on the top and the bottom, the 6k plus 1. So those can cancel each other off. And I'm left with, on the top I have 6k minus 1, on the bottom I have 2k minus 1. Again, I can't simplify anything else because they're being subtracted instead of multiplied. So that's going to be your answer. So all of this simplified down to that. Okay, this one's the same exact thing again. You would just factor it and then terms will cancel each other off. So I'm just going to skip that one. Okay, this one looks a little more complicated. It's pretty much the same thing. I'm going to rewrite it into a nicer form to look at. So I have k squared minus 4k minus 12 over 3k cubed. Okay, and then I'm going to write it this way, divided by k minus 6 over. Okay, so if you guys remember how to divide fractions, remember it's the keep, you change the sign, and then you flip your second fraction. So I'm just going to do that right now. So to change the sign, that means this becomes multiplication. And then to flip my fraction, I'm just going to write the denominator on the top now. And the numerator goes on the bottom. So I did keep, change, flip. This is what I have. Now I'm going to notice that I have the same term on the top and the bottom, that 3k squared minus 5k, or 3k cubed, sorry. Same thing, so those can cancel each other off. And then if I finish my multiplication, on the top, all I have is that k squared minus 4k minus 12 over k minus 6. We need to factor that top to see if I can simplify anything further. So it's k squared minus 4k minus 12. On the top, I have -12. On the bottom, I have -4. What multiplies to -12 and adds to -4? It's going to be -6 and 2. So because my a value right here is just 1, I don't need to do that box thing. I can just put these numbers I got directly into my factored form. So that's going to be k minus 6 and k plus 2 is the factored form. So I'm just gonna, here, I'll write it down here. So now I have k minus 6 over k minus 6. And you can probably see I have the same binomial on the top and the bottom. I can cancel those out. So I'm just left with k plus 2. And that's your answer. So all of that simplified just to k plus 2. So that's why simplifying is helpful, because it's a lot easier to work with k plus 2 than that huge number over there. Okay, now we're going to move on to N6. So that was N5. So N6 is going to be adding and subtracting rational expressions. So they're going to be fractions. So if you remember, for adding and subtracting fractions, you have to have the same denominator to be able to do that. So this one, we do have the same denominator. So your answer is just x minus 3 over wx, right? Just a refresher. So you're going to use that fraction button there. And that's it. So the goal is that you want to combine those into just one fraction. So let's try it for this one. Okay, so this one's a little bit trickier. Obviously, each of these has, well, only one of them is a fraction. But the goal is that we need all of those numbers to be divided by 2 so that they have a common denominator, and then we can actually go ahead and add them. So what I'm going to do is I'm going to take each of those. So 5d is my first term there. So I'm going to put that over 1. 5d over 1 is just the same thing as 5d. And I'm going to actually multiply it by 2 over 2. Now 2 over 2 is just 1. Like 2 divided by 2 is just 1. So I'm not actually changing my fraction at all. I'm just kind of scaling it up so that I have a fraction that's divided by 2 to find like common, so I have a common denominator. So I'm not changing 5d at all, I'm just writing it in a different way. So now if I multiply these across, 5d times 2 is 10d, 2 times 1 is 2. So 10d divided by 2 is the same thing as 5d, but I'm going to leave it as 10d over 2 because I want the fraction to be over 2. We're going to do the same thing with 4, my other term there. So I'm going to do 4 over 1 multiplied by 2 over 2. And then if I multiply across, I have 8 over 2. So 8 over 2 obviously is the same thing as 4. But the whole point is that I need the fraction to be over 2. So now I have 10d over 2 plus 8 over 2 plus the 3cd cubed over 2 already is over 2, so I don't need to change that. So I'm just going to rewrite it right here. So 3cd. Okay, great. Now I have all common denominators, so I can just add everything across. So now I have 10d plus 8 all over 2. And that's my answer. It can't be simplified at all, so, or factored, so we're just going to leave it. And that's your answer. Okay, this one is a little bit tricky. To add these, I need to have the same denominator again, right? So the denominator I have right now is the 6r plus 7. So I need to multiply every term, every other term, so that has a fraction, and the bottom is 6r plus 7. So how do I do that? Well, 4r is my only other term. So I'm going to multiply, first I'm going to make it a fraction, just divided by 1, same thing. And I'm going to multiply it by 6r plus 7 over 6r plus 7. Okay, so to multiply across, I have 4r times 6r is 24r squared. 4r times 7 is 28r. And then on the bottom, you just have 6r plus 7. Okay, so it seems like I'm making it a lot more complicated, but this is helpful because now I can combine it into just one fraction. So all of this is just the 4r part. So now let's go ahead and add them. So I had r over 6r plus 7, and I'm going to add plus 24r squared plus 28r over 6r plus 7. Well, I have the same denominator now, so I can just go ahead and add the top. So 24r squared, I have 28r plus r, so that's going to be 29r. And then the denominator just stays the same. And that's your answer. I can't simplify that at all, can't be factored. So I just leave it like that, and you're going to use the little fraction formula to enter that. And that's it. Okay, a couple more. This one's the same thing, so let's just skip that. Okay, this one could be a little bit tricky. What you're gonna do, actually it's the same thing as what we just did before. So I see that my denominator is this. I need to have W, I need to have that written as a fraction with that big number as or that big polynomial as the denominator. So we're gonna do the same thing. We're gonna multiply W over 1 times that huge thing. So this whole fraction, that just equals 1 because it's the same thing divided by itself, which is always just 1. So I'm not actually changing my fraction at all if I'm multiplying by 1. I'm not doing anything illegal. I'm just writing it so I have a common denominator. So let's go ahead and multiply across now. So on the top, W times W squared is W cubed. 26W, negative 26W times W is negative 26W squared. And then 30 plus 37W. Okay, that's the top, simple enough. And the bottom, all of that times 1, so that's just the same thing. So it's just W squared minus 26W plus 37. Cool. So all of this that I have now takes place of just that W. So I'm going to go ahead and let's write it over here. Now I have 4W plus 10 over W squared minus 26W plus 37. And now I'm subtracting this whole thing I just wrote. So on the top, W cubed minus 26W squared. Okay, and then on the bottom we had okay, so now this problem turned into this problem. But it worked because I have the same denominator now, so I can combine my fractions. So now I can just go ahead and subtract. So 4W plus 10 minus that big polynomial. Well, my W cubed term, that's my biggest term, and there's a negative, so it's negative W cubed negative W cubed. There's also not a 26 or a W squared term, so it becomes plus 26W squared. Okay, now I have 4W minus 37W, which is negative 33W. And then I have 10 minus, there's no other ones units there, so it's just going to be plus 10. Okay, and then the denominator is just the same thing, so W squared so I just brought the denominator down, right? And then that's your answer. Here, it's right here also. Again, helpful because now it's all in one fraction, so I can manipulate it a lot easier or use it easier than just having two numbers. This might seem like it's a more simple form, but it's actually helpful to have it as one fraction. Okay, that's it. So yeah, good luck with your IXL assignments. I hope you all have a great weekend. Actually, I guess it's Sunday now. Have a good week, and I'll be in office hours on Tuesdays and Thursday to answer questions you guys have. Okay, bye.